Good evening, Eugene City Council. We're here to talk to you about the potential flood scenario and ways to mitigate it.
Spring has sprung in Eugene, Oregon. At its surface, it is a time of life, vibrancy, and for many, it is a time of new beginnings. It is during this time that we often forget that it does, in fact, rain at Autzen Stadium. While this rain is usually harmless, causing only a slight inconvenience, or just an excuse for the outside world, it is not. In fact, sometimes it can be overwhelming. It can and has been globally destructive. Flooding is common to us in the Willamette Valley. Floods have happened in the distant past, and they have happened in the not-so-distant past. No matter the scale, Eugene is highly susceptible to all climatic and geologic factors that can cause floods, and we cannot avoid this. While the odds of a 100-year flood occurring are not exactly convincing at times, should we take such a risk ignoring its possibility? Or do we not understand the potential loss? It is because Eugene is constructed in what is aptly termed as a floodplain. In order to combat the nature of our setting, we have controlled the flow of our rivers. But these very devices could be our demise. It may not take only rain, but we are also aware that Eugene can be inundated with snow. All too aware. If large snowfall is followed by warm rain, the reservoirs created by these dams can quickly become a burden. And we cannot know this until it has already happened. What would we do? What can we do? How do we possibly prepare for such a catastrophic event? Or do we just, it will never happen? Write it off as a shot in the dark. After all, it never rains at Autzen Stadium.
Okay, so for some context, it is important to review a couple of the major floods that have occurred in the Willamette Valley as case studies. The most recent floods were in 1964 and 1996. It's also important to keep in mind that it did not only affect but every town along the river and developments on smaller rivers such as the Mackenzie and other tributaries. In December of 1964, a huge snowstorm occurred on the coast in the Cascade Range and in the Willamette Valley. After this, temperatures rose dramatically and there was heavy rain, specifically as much as 15 inches in valley areas. Lookout Point Reservoir, which was shown earlier in the video, received 8.17 inches of rain. Because of the frozen soil conditions from the earlier snowstorm, normal soil infiltration could not occur and there would be runoff. So this rain plus melting snowpack caused massive flooding. 3 lives over 210,000 acres of farmland were flooded, and there was over $157 million in damage statewide. Lookout Point Reservoir held back most of the inflow, and without it, the damage would have been significantly worse. Peak flow of the Willamette in Eugene was estimated at 60,000 cubic feet per second. The corresponding peak stage was 1.2 feet above flood stage. This means that water was 1.2 feet past the level where it could cause damage and threaten lives. Many residents were forced to evacuate their homes, and this was commonly called the 100-year flood. So obviously not supposed to look like this. It's the Cazadero Dam on the Plaquemines River, very close actually to where I'm from. And this flood completely destroyed the functionality of the dam, and it had to be rebuilt afterwards. The second photo is either this is a highway or the city. And the third photo is a steel bridge in downtown Portland. As you can see, the water level is almost reaching the bridge. So similar weather events caused major flooding in February 1996. By the end of January, where the Willamette drainage was at 112% of normal levels. On February 3rd, freezing rain occurred, followed by a strong subtropical jet stream bringing 5.17 inches of rain to Eugene in only 24 hours. The thing that was different between this flood and the before was that since then there has been significant increase in logging along the watersheds, which has increased runoff and clogged rivers with debris. This exacerbates flood conditions, and there's also been increased development along rivers. More homes have been built because homes on rivers are pretty, and which means that more homes have to be evacuated, and costs of damage were higher than previously. Around Kaiser, about 15,000 people had to evacuate their homes, for example, and there's about $19 million damage in Lane County alone as a result of the flood in 1996. So if these events were able to occur even with flood controls, imagine what would happen if a dam like Lookout Point were to become damaged and fail to hold back the flow. The results would be completely disastrous.
So in order to segue into the plausibility of a future flood occurring, I'm going to briefly talk about geology and geology specific to the Willamette Valley area, how this can happen. The driving force behind most flood events on the western coast of the United States is a climatic anomaly known as the Pineapple Express. And essentially how this works, it centers on the polar vortex, or the polar jet stream, which is the blue circle running around, and contained within that is the Arctic Circle, cold, air, high pressure. Now what can happen, specifically in the winter, and especially with recent climate trends, is the northern hemisphere can cool so much that a high pressure system sort of seeps out of the Arctic Circle and blocks this jet stream. Now if you imagine placing a stone in a creek, you can see the water going around either side of it. Well, that's what happens here. You get this southern stream going down toward the latitude of about Hawaii and picking up very moist, very humid air and essentially bringing it up and spinning it on the Oregon coast. And if you pair this with ocean oscillations, such as the Mid-Julian Oscillation or the El Nino Southern Oscillation, very erratic temperature fluctuations that we haven't been able to predict very well. The air that it picks up from the tropical area can contain so much moisture that it can inundate us with rain. And it's like, this is a visualization of a Pineapple Express event. You can see how low the jet stream will reach, and it's essentially running right into the Oregon coast where we are. Next slide. Eugene sits at the base of the Willamette Valley, which is essentially a gigantic floodplain. And that figure on the right shows all of the tributaries that run into the Willamette River and how much water is essentially settling in this area. What we are concerned with is, next slide, this area, which is just upstream from the Willamette River. Essentially, I think it's Fall Creek at that point, it's not yet the Willamette River. But you can see in the zoomed in portion, that's Lookout Point Reservoir. Below that is Dexter Reservoir. There are two dams there. And a couple miles upstream of Lookout Point Reservoir is Hills Creek Reservoir. Combined, these three dams contain, at any point in the year, just around a cubic kilometer of water total. Now, to sort of lay out what can potentially happen, let's say Eugene gets quite a bit of snow. We saw that twice this year. It happens more frequently than we like to admit, and we are not prepared for that. Nonetheless, what can result from it? But to put in perspective, the February snowpocalypse that left our city completely in shambles structurally put about 10.5 inches of snow in Eugene. The record in February of 1969 for the most snow in one month is 47 inches. Now let's say we get somewhere in between that, and now there's a bunch of snow in the mountains, a bunch of snow in Eugene, and then a Pineapple Express event comes in containing a lot of moisture, a normally warm Pineapple Express at that, and melts the snow, dumps rain on top of it, and it all has to deposit into these reservoirs. if we haven't controlled these reservoirs aptly, then the dam is in danger of failing due to erosion from water spilling over it, landslides that could potentially give way. And if that's going to happen, then essentially Eugene could be screwed if we're not ready.
Alright, you guys may be wondering how probable is it that this flood will reach Lane County, and this is provided by FEMA. It's the 100-year flood map, and as you can see, the dark orange areas are the areas that will be affected, 1% chance in a given year. And you can see the different rivers that surround Eugene, and typically, the Willamette River, the Middle Fork one, will be the one that will impact Eugene if the dam And this is just a basic data table showing how to figure out how likely it is that a flood will occur. So I took the years of the major floods that occurred in Lane County, which are 1861, 1890, 1945, 1956, 1964, and 1996. And I took the differences in those years and averaged them. And once I did that, I found that there's a 1 in 27-year chance that a significant flood will occur in Lane County, which is equivalent to 7%. And according to the Eugene and Springfield Steering Committee, an event that's likely to happen within 10 to 35 years has a very high probability of occurring. So this, as you can see, is a major issue in Lane County. This is showing just Eugene, mostly the metro area, and some statistical data to show you how serious this problem is. The total land area is about 30.9 square miles. The affected land area is about 8 square miles, so that's a fourth of Eugene. And the total population affected will be about 25,117 people. For buildings, there will be 4,460 in the metro area that will be affected, 3 of which are schools. As for streets and roads, 61 miles in the metro area will be affected. And 2 fire stations will be affected, which is also a problem since that's one of our sources of help if there were to be a flood. And water and wastewater treatment plants are at high risk just because they're very at low. So one thing that the FEMA map doesn't really take into consideration is the elevation of buildings. And so just to give you guys an idea, the elevation of Eugene is about 425 feet. And as you can see in that graph, there's a high risk for buildings that are between 434 and 437 feet elevation. And one thing to keep in mind about the FEMA 100-year map is that they don't really take everything into consideration. So like even the minor details, such as small streams, those aren't really accounted for in the map, and so there is a need to take it with a grain of salt.
Okay, so now Aubrey and I will talk about a few policies that will allow us to be flood ready. So preparation, protection, response, warning, recovery, and reconstruction. Okay, so in order to prepare for a flood, we have a few emergency services. And I will show you this on the map in a few slides. We have a few fire departments dispersed throughout Eugene, but the one thing that I found really problematic is that there's only one fire department in the middle of the most dangerous zone on the flood hazard map. The fire department has a water rescue team that has several, I think it's 4, and I'll show you on the map again, 4 launch points off of the Willamette River that will be able to aid and assist people in that danger area in case of a flood. And then also, we have developed a team called Community Emergency Response Team. And what this does is it allows members of the community to volunteer to be trained in order, in case of a flood, to be able to assist other members, just in case there's like no fire department's able to get to a certain point. Kind of the idea of if no one can help you, well, what do? You have to be able to help yourself. Eugene is part of the National Flood Insurance Program, and as part of that program, we volunteer to participate in the community rating system, which essentially works to reduce flood damages to insurable property by encouraging communities to go above and beyond the minimum requirements for flood management, and they do this by providing them with discounts. Also, we have developed several dams which have proven to be very successful in the past floods. This is a picture of the Lookout Point Dam, and some structural mitigation measures. Well, the problem is that all buildings that are new are required to meet building code for flood hazard zones. The problem is that a lot of buildings are decades and decades old, so buildings do not meet these standards, and they're in the flood zones. And so these are some of the standards required by FEMA: installing sewer backflow valves, building with waterproof materials, and that includes waterproof linear to exterior walls, electrical components out of the water line, anchoring fuel tanks, and building above the flood line. So, in case of a flood, this is a map of the flood hazard map that FEMA has drawn out. And as you can see, in case of a flood, there's going to be heavy flood to the north, so we can't evacuate to the west because we'll hit the coastline. And we can't evacuate east because that's where the cascade is, that's the flood. So the only way to evacuate is south. This is the danger zone I was talking about earlier. This is the one fire department that we have, and then the 4 water rescue. And so I want to stress the importance of having a very effective alert system, because in case of a flood, all of these people are going to be trapped if they don't evacuate quickly enough. So I-5 becomes a major route, and then if the flood has already hit I-5, then the Beltline Highway is also an option. And then, yeah, so, oh wait, and then, so, let's see. Some of the problems with the mitigation that's already in state is that, as I mentioned before, there's only one fire department, and the stormwater drainage system in Eugene is not adequate enough in case of a flood, and so that also causes a lot of urban flooding. So all of these areas that you can see where that would be affected, all of this light blue color, would actually be a lot more extensive, so it could reach out more towards here just because of urban flooding. Another problem is that FEMA, the last time that they actually updated these maps was June 2nd of 1999. So topographically speaking, Eugene could have changed a lot in the last 15 years. And then also, as I mentioned before, a lot of developments are not up to building code, and they sit right in riparian areas.
Okay, so we also have some policies for warning. We use the FEMA IPAWS warning system, integrated public alert and warning system. They have all these technologies available. As soon as we know about a flood and authority in Eugene, we can tell IPAWS and they'll send it out using all these mediums. So that's when you see it'll pop up on your TV, they'll send you a text. If you have your internet up and running, it'll show up on that. But it can also be kind of bad for people who have technology around them at that time. So they could also have more access to digital and giant voice sirens outside, just for people who maybe don't have their phones and they're out walking around or something like that. And there could be a lot more pre-flood communication, education about it. Right now they have a mailing pamphlet they'll send out to everyone who's in the flood hazard zone. That's really easy to just throw away and never look at or fully read. So they could have seminars or required classes if you live in that area, or do an evacuation drill once a year or something like that. So there's a lot more potential to be more prepared and have a better warning system. And sometimes even if you get that warning out, a lot of people aren't going to listen. So for recovery and reconstruction, if you don't have a lot of policy for that at all, for water removal and cleanup, that's going to be one of the biggest problems. Casualties aren't a big deal. A lot of people are able to escape, but a lot of them become homeless because their houses are ruined by the water. You can see even if it's just a couple feet, you get this mold growing that is really hazardous to breathe, and you may have to reconstruct the entire wall or all your flooring, which can be really expensive if you don't have insurance. And so we have one company, Restoration-Ease, this private company. You'll have to pay them to do this. You can see there's multiple fans just in one room. If all 4,000 buildings or so get ruined in this hazard area, they're not going to be able to take care of them all very quickly at all. And so there's another thing we need to think about is the public health and homelessness. Where are all these people going to go? How are they going to get clean water and food? And for damage assessment and repair, so there is flood insurance required in the special flood hazard area. But like we said, a lot of these buildings are still not up to code, and there's not a lot of policies for people who are going to help to rebuild or partnerships with building companies that are prepared to deal with a situation like this. Okay, so this is from an expert at permatopia.com, potential impacts of dam failures on the Eugene Springfield metro area. It kind of takes inventory of all the different impacts that it can have. And the major things to notice are the heavy damage to buildings, which I talked about, the major damage to water and wastewater treatment plants, which is going to cause the water to be unsanitary to drink, and just basically the whole area unlivable. And then potential for high casualties, especially in a dam failure, and like I said, even more so the issue of homelessness. So then we go to a cost-benefit analysis of which one of these modes is going to be the best to focus on. If we focus on just preparation, well, I can tell you first, the highest damage that we had is about $25 million. That's $6 million over the cost of the '96 flood, just because there have been more buildings built in that time, and a dam failure is going to cause a lot more damage than just a regular flooding. And the highest casualties at over 5,000, that's about 20% of the population in the hazard area, but it could go up a lot more depending on if we're ready or not. For preparation, that's not going to cost the city a whole lot, making sure the citizens are educated, doing classes, setting out pamphlets, that kind of thing. But people aren't always going to listen to those things, so the casualties are going to be high, and that's not going to protect the buildings at all. If we focus on protection, such as making sure building codes are enforced, making sure the dams can hold back strength of water and that they're not going to break, there's going to be, you can actually maybe even prevent the disaster from ever even happening. So casualties could be as low as 0, and damage could be, maybe there could still be damage from rain or flooding of other minor rivers, but it would be very, very low. If we focus just on warning people, then that's also going to be very low cost, but very high casualties. People aren't going to listen, or maybe they don't even get the warning signal. And again, that protects not at all for buildings and damage against roads. If we focus just on response, it's going to be really, really expensive to get all those fire and police officers and whoever else to come and try and save everybody and evacuate and scramble. It's going to be widespread panic, lots of casualties. Maybe you do get a lot of people out, but it's still going to be really expensive to fix and rebuild. Same with recovery and reconstruction. It's going to be very, very costly, depending on how many people have insurance and that kind of thing. So we can clearly see that protection, although it's in a mid-range cost, it's definitely the most beneficial route to go. Of course, we want to have a combination of these things in our plan, but it's very important to focus on protection, where we could stop this destruction from ever happening.
be making sure that everyone has insurance. 30% of the flooding that happens is outside of the special flood hazard area, so those people need insurance too, not just people who are in the area. Making sure that the building codes are enforced, such as having fines that are greater than the cost to fix the house. Reinforcing the dams, and they already do drain the dams at peak season, so making sure that keeps happening so the water level is low enough where the rain won't spill it over. Having a greater understanding of the forces that cause, which can be just part of education and public education.
Okay, thank you. All right, now let's have the final